So we are going to go and we're going to finish up those questions, and we are going to go to Steve Beuning. Steve is the manager of market operations at Xcel Energy, where he's responsible for wholesale electric market design, renewable energy integration, transmission system open access, generation interconnection, congestion management, as well as congestion hedging. He's the immediate past president of the Utility Variable Generation Integration Group, which is UVIG, and it's a utility forum that brings utilities together to share information on operation and maintenance of wind and solar resources. It's a really great group for the utilities. Steve is also an appointee of the California Independent System Operator Energy Imbalance Market Transitional Committee, so he's helping to plan a system so other utilities can join the energy imbalance market. He has worked for Xcel for 31 years, so we're real pleased to have Steve with us today. And Steve, you can take it away.
Okay, thank you, Amanda. Could we go to the next slide, please? I'm not seeing the next slide.
Yeah, I'm not either. Graham, next slide, please. Okay, hold on just a second. Folks, we were having some problems advancing slides when we started, so just a second.
Ah, there we go. It looked like we jumped two, but that's fine. I'll just jump right in. Oh, there we're back to the outline. I'll talk for a few minutes about the value of wind and then go into some gory details about how we've changed our utility operations in response to the amount of wind that we currently integrate. And then I'll leave some time at the end. So if we could go to the next, we can have Q&A at the end. Some of the value areas that we see for wind resources lie in the environmental responsibility area. Our utility has been ranked by AWEA as the #1 wind energy provider for the last 11 years. We're listed in the Dow Jones Sustainability Index, so we do get some recognition from the industry for the role that we've played as a leader in our environmental responsibilities and in integrating renewable resources in our generation portfolio. I'll talk a little bit about resource planning, one particular aspect of it regarding renewables. I'll talk about it as a hedge against fuel prices, and then some comments about the future. So if we could go on. I think the biggest thing with respect to wind and solar is that it's no longer a special. It's no longer a unique or one-off type resource. It's something that is a competitive wholesale electric supply resource option in its own right. And we integrate them into our portfolio of generation resources in our planning process, just like any other option. And recently we've been seeing wind and solar resources turn out to be the most economical option in their own right, regardless of the state regulations that may be putting renewable portfolio standards obligations onto our utility. So our utility is on track to reduce its emissions 30% from 2005 levels. Currently, you see the stats there on how much of our annual energy obligation for our customers is supplied by wind. We average 15% across all three of our operating companies. Public Service Colorado has 21% of its energy supply in 2014 came from wind resources. And I just think it's funny, I think back in my career in the mid-1980s, our utility, Northern States Power, was putting in 3 100-kilowatt wind turbines in southwestern Minnesota in a town that was named Holland, actually, by the way. But you know, I remember our traditional plant operators saying, you know, it's never gonna succeed. There's no way you could make anything like that fly. So from that 300 kilowatt scenario back then, we now have 5,740,000 kilowatts in our portfolio of owned and contracted resources that we integrate. Let's go on. We have a 20% annual energy, I'm sorry, a 30% annual energy portfolio standard for our Minnesota and Colorado utilities. Just I'll throw that in on the last slide. I did want to talk about the value of wind in the resource planning process. You know, resource planning addresses two somewhat distinct aspects. One is the adequacy of resources, to make sure that enough generation is available at all times in order to meet whatever demand is being imposed on the system by customers. The second value in resource planning is around the cost of the energy that's used to supply those customers. So a lot of times when I've heard people talk about wind resources, I've encountered confusion on the distinction between the resource adequacy value of wind and the energy value of wind. If we had a 100 megawatt wind farm, for example, from the resource adequacy standpoint, we might only count 10 to 15 megawatts of that capability towards our reliability margin, and we might have to procure 85 to 90 megawatts of other type of resource that could be dispatchable in the event the wind wasn't blowing. So that resource adequacy discussion is one value, and because of that discount on the wind resource being able to be there when needed, that's typically not the basis by which wind and solar are selected in our resource plan. Usually what we see is that the value of those resources come just in the energy supply, because they displace fuel that we otherwise would have to burn at a coal or natural gas plant. And that displacement or fuel cost savings combined with the increasing capacity factors, I think Mark mentioned the newer stuff is coming in, he said, above 50%. The higher you can make that number, you not only get the energy value out of it, but the higher that number is, the better the contribution in the resource adequacy component as well. Let's go to the next slide. I wanted to give you this fine print here. I'm not going to read it, and I apologize for the fine print, but I just think the content of these excerpts from some of our integrated resource plans is of interest to this group. We see hundreds of millions of dollars of savings for our customers over the life of some of these renewable resource additions that we've made at our various operating companies. And that's not even taking into account, in all cases, the fact that there may be costs assigned to CO2 emissions in the future as the Clean Power Plan or other environmental initiatives start ascribing a penalty or a cost associated with carbon emissions in the future. Next slide, please. So with that, I wanted to dive into something to think about in the future. As you integrate higher and higher levels of renewable resources, you get into the situation where there will be curtailments or increasing curtailments of that renewable resource. Just because to drive up the annual average component, a utility has to install more resource than they can necessarily accommodate at all points in time. I had the Mid-Continent ISO in the Midwest has done planning analysis projecting if a utility were to take 80% of their annual energy from wind and solar, how much resource would they have to install? And this was of interest to me because as a regulated utility, I'm used to a dialogue with my state regulators where we look at a prudent level of installed generation capacity to be, you know, traditionally it was in the neighborhood of 15 to 20% above your annual peak demand was the amount of dispatchable fossil or thermal resource that a utility built. If they built more than that, the regulator may have deemed them imprudent. But as we go forward into a renewable future, if we look at 80% annual energy supply from renewables, a utility in the Midwest might install 3 times its peak demand in wind farm nameplate and probably 1 time its peak demand in solar nameplate to get to that 80% annual energy target. And in doing that, there would be probably 3,000 to 4,000 hours a year where there would be some level of curtailment of the renewable resource because there wouldn't be an equal or greater amount of load on the system at the same time. Now that brings me to this slide here, where today there's a prevalence of power purchase agreements for renewable resources where the utilities are obliged to take the energy from the renewable resource, or if they have to curtail the renewable resource, pay them anyway. But I think as we look towards this future where there are higher and higher levels of renewable penetration, it really makes the business case for utility ownership of the renewable production asset, because then it can provide the cost recovery on a capital basis instead of a purchased energy basis. And it can be indifferent to the level of marginal curtailments that might take place on the resource. So let's go on and we'll switch gears to operational and system modifications. These are some of the areas that I'll talk about in this section. Let's go on. We have the next, oh, there we go. So probably one of the most fundamental things that has changed with the addition of renewables in our portfolio has been our attention on forecasting. Utilities used to be able to get by just looking at the average temperature profile in their footprint for the next day and some degree of cloud cover estimation, and from that they could predict what their customers' load would be with pretty good accuracy, in the 1% to 3% range of error. What we saw with wind resources as our portfolio grew was that on a day-ahead basis, we were running 16 to 20% mean absolute error in our day-ahead forecast of the wind output. And there's an area of controllable costs that you can manage with better forecasts, and that relates to the backup supply. You may have to commit backup supply, other generators, to address the variability no matter what, but it's that uncertainty that's the controllable cost piece. And if we start a gas turbine this hour because we think the wind is going to drop off, but then it doesn't actually drop off for 2 more hours and we didn't need that gas turbine, that was a cost our customers had to pay, which we could have managed with a better forecast. And what we've seen is by working on improving our forecast accuracy, and now we're down, I don't mean to brag, but I think we're as good or better as anybody in the industry with a day-ahead mean error of 10 to 12% now. And we estimate that just in this aspect of controllable costs on backup supply, we've saved, like in 2014 alone, probably about $14 million in operating costs. Let's go on to the next slide. Another area where we've seen benefits is the development of regional markets. When utilities pool their dispatch, it increases the number of resources that can respond to variable resource balancing obligations. It also creates a diversity effect, where if I have one unit of variability in one balancing area or utility footprint and a unit of variability in another utility footprint, and I combine them, those two variability effects are not coincident, and so through combination of utility footprints in operations, we get an efficiency saving through a diversity benefit. For those of you that are math geeks, that 1 + 1 = 1.4, that's the same thing as the square root of the sum of the squares. And that's definitely a benefit we've seen in regional markets. So there's another benefit to regional markets too. Oh, thanks. I take that as a notion I should speed up a little bit. We went on to, I have some slides here that are 3 slides on tangent. This is just to give you a brief lecture on the benefits of regional markets, but I tell you what, let's skip that and we can come back to it if there are questions. Can we advance to the slide that says modification bilateral markets?
Steve, this is Amanda. I don't think we meant to speed you up. I think Graham switched the slides, but we're not trying to speed you up. So if you want to, okay. if you want to go back to that slide, let's go back and finish it.
Okay, well, I will try and speed up, though. I notice as I look at the clock, I'm running. So if we can advance one from here, the slide that says tangent in the upper corner. Amanda mentioned that I'm helping in the development of the energy imbalance market in the Western Interconnection. I couldn't pass up the opportunity to talk about why regional markets provide benefits. They reduce the cost to transact, and when I talk about transactions here, I mean the wholesale electric market transactions that maintain balance between generation and load. And the need for those type of transactions is emphasized as there are more renewables being brought into the mix, increasing the variability on the generation side of the equation. Let's go on to the next slide. There's one other detail in this cost to transact as well. In the bilateral market areas like we have in the majority of the western U.S. states, there's something called a rate pancake. And for a transaction to occur from one utility to another, there has to be an access charge paid for delivery service on the grid. Let's go to the next slide where that's kind of illustrated. So in this slide, we have three utilities, A, B, and C. And utility C right now is operating at the highest cost. It's costing them $50 per megawatt hour to produce energy. And systems A and B both have energy that they could sell at those prices, but because they have to pay this grid access charge, system C actually is not going to buy any of that energy, and it's going to forego an efficiency benefit opportunity because of the current structure that we have around grid access and payment for the costs of the grid. And one of the things that regional markets deliver that's a contrast to bilateral markets is this pooling of the dispatch is accompanied with a new transmission tariff design that eliminates these delivery hurdles. And then in a pooled dispatch scenario, System A would be supplying power to System C and reducing some of their operating costs. So I appreciate you bearing with me as I went off on that tangent, but let's go on to the next slide. In the western states and for our utility in Colorado, we still are in a bilateral market, and we pay these delivery access charges. But one of the things we've done here to improve efficiency with renewable integration is we've established a tariff proposal which is pending at the Federal Energy Regulatory Commission right now. We've established a type of product called flex reserves. And really what we're doing here with this is we're giving third-party renewable developers the opportunity to integrate wind at as good a deal as we provide for our own resources at our own utility. And I would just characterize this as being in contrast to some of the operating practices of other utilities in the Western Interconnection that impose a much higher cost of renewable integration on third-party producers that interconnect to their systems. And they do it because they, I'm trying to think of a diplomatic way to say this, because they say that the reliability requirements they are obliged to maintain are so severe or strict that they have to have these really high costs for integration. In our own experience, we've seen that we can integrate without incurring those high level of costs, and that's what we're attempting to pass through with our flex reserve tariff. So let's go on. Next slide, please. Another area where we've modified our system operations in response to all of the renewable resources is with our dispatchable thermal resource fleet, where we see increased cycling. By that I mean shutting them off and turning them back on, and increased ramping, where we run them up and down from their minimum to maximum operating points. The problem with that on our dispatchable thermal fleet is that increases stress on systems and components inside the plant, and that leads to predictions of increased forced outage rates. So this cycling impact, you may have heard, for those of you that have monitored some of the renewable integration discussions, it's a real concern. And we also have that concern. We've been able to mitigate some of these concerns through projects that improve the control capabilities at our plants and through increased plant operator training so that we don't, or that we try and minimize the thermal stresses on the boilers that could occur due to ramping. So just to reiterate, we can mitigate the need for ramping through regional pool dispatch, and when we do have to ramp, we can mitigate through some of these internal measures. Well, let's go on to the last slide in the modifications area. The industry operates under standards, as we all know, and NERC and the NERC regions and other standards organizations establish requirements on the utilities that are mandatory and that can include financial penalties for failure to comply. So getting the rules right with respect to reliability standards is really important to make sure that we have an industry that's accommodating to renewable development. And for example, there's a new standard that's undergoing field trials right now that would relax the burden on utilities to maintain the generation and load balance. If you look back 15, 20 years ago, this utility industry kept very tight regulation on the grid frequency. You know, we were a 60 cycle grid, and of course we still will be going forward. But whereas we might have been 60 with a very minor set of swings around 60 hertz, 60 cycles per second, in the future, I think that will relax somewhat because there's little fundamental reliability reason why the boundary on 60 hertz needs to be so tight. And the field trial that's underway will help relax some of that. And that's good news for renewables by reducing the cost allocation to them for backup and regulating resources. There's some other developments around the NERC Essential Reliability Services. If you Google on that, you'll get more information than you want to read, but it boils down to the ability of renewables to provide ancillary services, things that support the operation of the grid, and in most markets, renewable resources like wind, for example, are excluded from being allowed to even provide those type of services. So there's things the industry can do in standards efforts in those areas to improve the commercial product lines that wind and other renewable resources can participate in. And then lastly, there's something under the NERC standards that I think is a future interesting issue. As wind and solar increases in interconnection, it ties to the electric grid through a DC inverter. And because of this DC connection, it does not provide naturally system support for the frequency at 60 hertz. So this support is sometimes characterized as an inertia response. And there are a lot of technical issues around the inertial response on the system as renewable penetration increases. I think that will be a field of endeavor over the next decade for utility engineers and geeks to participate in. It should be a lot of fun. There's one last thing I forgot to put as a bullet on this slide that folks might be interested in, but there are different standards for a concept that Mark mentioned in his presentation called ride-through. The ability of a renewable resource to stay connected to the grid in response or at the same time to a disturbance that might occur on the grid, say due to a lightning strike or something like that. And right now there's a standard that applies to the distribution system connected utilities. It's called IEEE 1547. In that standard, distribution connected resources are supposed to trip offline. And at the NERC standard level for the bulk electric system, resources are supposed to stay online and ride through. So there's an important industry standards effort underway right now to reconcile these 180-degree conflicting requirements on resources that are interconnected. Might also be an area folks are interested in if they want to pursue the topic further. But I think with that, it takes me to my last slide, and if there are questions, we can talk about that.
Steve, thank you so much. So, folks, if you raise your hand, we can unmute your line and we can ask your question, or you can do the little question thing and type in the text box. I've got a couple. The first one is, you had mentioned early on all the work you had done about your forecasting improvements. The question is, were the forecasting improvements mainly software changes, so you're actually seeing wind patterns more, or were there more adapting your operators to respond to information they were receiving?
Oh, that's a fabulous question. The answer is it was the addition. It was an effort in a lot of areas. It was an addition of meteorological inputs into the model. And it was a step away from the National Weather Service model, which is just refreshed every 4 hours, to a model that we worked with the National Center for Atmospheric Research in Boulder. The distinction with their model is it's a continuously updated real-time model. And so it doesn't have this stale data refresh issue that we had with the old National Weather Service model. So between the increased meteorological inputs from all of our wind farms that gave better situational awareness to the NCAR forecasting model, the use of that improved model, and then over time the training of the model. I'm not a neural network programming type person, but I think that that's the software technology that Global Weather Corp is using. They're the vendor that has applied the model that I was just talking about. I think that they've neural net trained it. Excellent.
Okay. So here's one I'm going to read you from the web. It says, is FERC the forum for a multi-utility transmission tariff to reduce hurdle rates? Who would be appropriate entity to bring that kind of case?
Oh, wow. Hey, these are high-quality questions here today, Amanda. Ultimately, FERC would be the forum. But just as an example, our utility, Public Service Colorado, is working with other neighboring utilities in Colorado. And we're trying to tackle this on our own to get a design for a multi-utility tariff that's acceptable to the parties, which we would then bring to FERC if we succeed for FERC's approval.
Okay, excellent. Next one, would you describe how Public Service of Colorado control operators, quote, parked, unquote, fossil resources while depending solely on wind for system regulation? And then part two of that is wind resources beyond AGC, which I think is automatic generation control. So did you get the question?
Yeah, I think so. Okay. Parking fossil resources sounds to me like an operating scenario where we have relatively light load and relatively strong winds. And so we take our dispatchable resources that we do not want to fully shut off down to the minimum operating level that they can sustain while remaining online. So to me, that's what parking would mean. If the questioner meant something different, please ask again. But when we have that type of operating condition, it's interesting, but the marginal unit, the one that can vary its output to keep supply and demand balance, becomes the wind resource. And we do have automatic generation control, or AGC, capability installed on about 1,200 megawatts of wind on the PSCO system, which is more than enough for us to regulate during those minimum load type conditions. We've done that on our other systems. And interestingly enough, what we're seeing in the large regional markets is that has now become a required condition of interconnection for large wind resources, is that ability to vary their output in response to a dispatch set point.
So I make sure that people understand when a wind turbine's on automatic generation control, it means that you have the ability to control that turbine just like you would any other generator. That's assuming the wind's blowing and the turbine's online.
That's right. And the preferred operating mode for a renewable resource is take every megawatt you can, because it's every megawatt we take from the renewable resource, we're avoiding burning fuel at a fuel cost in other plants. So the preferred thing is to put them, we call it, at the bottom of the stack, where we take all that's available from them and then use the burning of fuels to fill in the remainder. But when we do have these minimum load conditions where the resources that burn fuels are parked at the bottom, then we have to continue to maintain balance between generation and load by reducing the output of the wind farm. They become the marginal resource.
Right, right. So they're more controllable. So we have 5 minutes left. I've got a number of questions, so I'm going to keep asking. If anybody on the phone has questions also of Mark or of Karin, please let me know and we can ask those as well. Or Mark, if you have questions of Steve or vice versa, let me know. This one, there's a couple around this, so I'm going to kind of combine them. It's around markets. You had talked about all the work and the benefits you see of markets. What is your consideration of joining the energy imbalance market, and then are there other markets you're thinking about joining?
Okay, I can answer that. One of the things that we evaluated in Colorado was whether there was an opportunity for us to interact with our neighbors quickly and relatively cheaply compared to the cost of a large regional market. And the answer to that question was yes. We have two other relatively large utilities that are in our utilities balancing area. They are Platte River Power Authority and Black Hills, Colorado. With those two utilities, we filed at FERC a proposal to create kind of a mini balancing market just inside this footprint in Colorado. FERC responded with some concerns, and those concerns we are reevaluating right now, but I do believe we will go ahead and attempt to address FERC's concerns and resume the development of that local dispatch pool. But in the broader context, we're also looking at the other regional options that are available to Public Service Colorado. We certainly have been involved in the development of the energy imbalance market and are monitoring that in order to see whether it would provide benefits to us in Colorado. We have a logistical issue with the energy imbalance market. We have no direct interconnection to it right now, and we would have to evaluate additional costs beyond just the costs of the market in order to assess whether that development would provide benefits for our customers. Beyond the California ISO energy imbalance market, there's another venue to our east is the Southwest Power Pool. There are technical ways that the Southwest Power Pool could be brought into the Western interconnection even though it currently operates in a separate electric interconnection. And right now we're at the stage, Amanda, of just evaluating the potential for all of those to bring benefits to our customers. We would still need to engage in a dialogue with our regulators before we took any action beyond what we've started already. So time will tell, but we're sure interested.
Great, thank you, Steve. So Mark, if you're available, this question's for you. It said that you assessed a number of technical issues that GE and the wind industry is going to be working on in the future, but they're asking, could you point to a single technical issue that is going to be a key focus to watch for wind development over the next 5 years?
Huh. No, not really.
Okay, so all of the above we'll still be working on.
Yeah, I mean, I just think about the the components of a turbine, and Machine heads are in pretty good shape. Rotors are in pretty good shape. Towers are in pretty good shape. No, we're at 98% availability in the industry, so our quality is actually pretty good.
Okay. Steve, is there anything you want to comment on that question? Are there things you're watching for that you see that could be improvements for wind?
Well, one of the things I think is interesting, and it's not in the wind plant itself, but Mark did mention the potential impact of low-cost storage. I do think that would be an amazing development if we could see that. It's certainly something at the utility we're thinking about, the what-if scenarios. And I think there are price points for storage at which, even though you've got efficiency losses because you put some energy into storage, you lose energy when you take it back out. Even with those efficiency losses, there's price points at which it would be economic to install, and that will have a big impact on utility operations. We would see fewer curtailments of the renewable resource output as we get to higher levels of renewables in the portfolio.
Gotcha.
Yeah, no, and I'd agree with Steve. I mean, I think the next frontier is integration of new things, and does that integration create a feedback problem in some instances? So those are things that we're definitely looking out for.
Okay. The last question I have is kind of a global one, so it's probably a one to end on, and it says the upper limit for Xcel for wind penetration was 61%, and I guess that's at some point in time. What do you think is the average energy that could come from wind turbine over the next 5 to 10 years? So I think the questioner is asking about how much could wind provide? Could it provide 50% of your energy, 60%, 80%? So I'd ask Mark the same question, that in the utilities that he works for, what do you think is the upper end for wind penetration, and over what time period?
So I've seen public studies by different serving areas that say 30% wind penetration is realistic. There is a pathway to that today. I've seen that for the Southwest. I've seen that for the Midwest. I've heard about it in Maui. I mean, lots of different situations where there is a way forward for 30% or more.
Okay. And Steve, how would you answer that question?
Well, I agree with what Mark said. I'd add on to it. We did an analysis with all the utilities in Minnesota last year called the MINRITS, the Minnesota Renewable Integration Transmission Study. We love acronyms. And we looked at 40% and 50% annual energy. As you start getting into those ranges, there can be some inertial or system relay protection problems that could be addressed. And the study didn't have enough time to complete its conclusions with respect to 50%, but we did conclude that at the 40% annual energy level, with modifications to address issues around inertial and short-circuit current ratios, that 40% would be achievable. There were transmission upgrades that were necessary too. To get to that level of average energy production, you have to have a grid that can slosh the energy around more so than it can today. But with those modifications, it was feasible.
Excellent. Okay. Well, I want to thank Steve Beuning and Mark Rush and Karen Wadsack from NAU for joining us for this webinar. This has been recorded, and so this will be placed on the Four Corners Wind Resource Center in case you want to go back and review some of the information. Greatly appreciate all of our speakers' time and everybody joining in, and we'll send out a notice when we design the next one. So thank you very much.